Hi, everybody. Welcome back. This is OffChain Code, Beginner Web3, and this is the fourth lesson. Today, we're going to be going through functions. Before we get into that, OffChain is a global community for blockchain enthusiasts. So if you've not checked out our website, I highly recommend going to offchain.social, or you can join any of these WhatsApp, Telegram, or our WeChat apps to get connected with a group in your city. And this is a great way of meeting others and continuing to learn. So a little bit about myself. I'm American, but I've been living in Guangzhou, China for the past 3.5 years. My background is in software development, but I don't normally work in doing smart contracts, but it's been a personal hobby of mine since 2013, as well as professionally. If you want to connect with me, I'm on WeChat. You can scan my WeChat code in the lower left-hand corner. Or if you want to give me a tip, my Ethereum address is in the lower right-hand corner. And I love to travel, so feel free to reach out to me and by any means necessary, and I'm happy to talk about anything that you guys want. So again, this point of this class is not to make you guys professional developers. It is really about getting an introduction to Web 3.0, explaining some of the basic concepts. And we're picking JavaScript as a basic starting language because it is what most web browsers are using out of the box. And we're using Solidity because it is widely the most popular smart contract language. But it is a starting point. You guys can keep learning from here. And there are many, many other blockchains and other Web3 technologies that are going to become really important as this space continues to grow out. So as I mentioned, this is lesson 4. And what we're going to be diving into today is going to get into the weeds. We're going into the JavaScript functions. And functions are something that aren't just specific to JavaScript or any programming language. Really, every programming language out there, at least modern ones, has the concept of a function. And we're going to take a look at the end of this class at how Solidity does it, the one that we're going to be, the programming language we use for smart contracts. So at a high level, what is a function? It's really anything that takes optionally an input, meaning some sort of variables that we want to pass on in. It then does something, which we can loosely call a procedure, and then it returns an output. The return is, again, optional. It is possible to return nothing, but for most functions that we think about, you're passing something on in, you do something to it, and then you take the result and put it on out. It almost behaves like a little program, and that's exactly what it's trying to do. It's encapsulating some logic and then allowing us to reuse that so we don't have to always remember to type out everything over and over again. It's actually just a shorthand way of saying, do the same thing I already described how to do. So a really basic example of this, we could define a function by using the keyword function. We can give the function a name like square, and then we can pass optionally an input saying it's going to take a variable called number. Now, I use the word number, but I could have passed it anything as the variable name. You then see it uses the curly brackets, and then you can do one or multiple steps as the procedure for this function. In this case, since I'm taking the square of a number, if you remember back to your algebra classes, when you take the square of a number, it means take the number and multiply it by itself. So number times number, and return that. That now has defined a new function called square, which we can now use once or many, many times throughout the rest of our code. So really basic question. If we say var x equals square 5, anybody want to quickly unmute and say what x is going to equal?
25.
Very good. Okay. This is not very hard, but it is fundamental building block for every single modern programming language out there. Why? Because we don't want to have to keep repeating ourselves. If we're defining how to do something, whether it's as simple as taking the square root of a number or something as complex as painting a picture on the screen, these are all complex functions that we're going to likely want to reuse over and over again, and they become a building block within a programming language. So we're going to take a look at lesson 4 and probably spend the majority of the class in lesson 4 on Code Academy looking at functions. But at the end of the class, and perhaps as homework as well, I want to introduce Remix. Now, this is the fun part. You know, functions sound pretty boring and yeah, you got to learn them and blah, blah, blah. But what you can do with them is pretty cool. Remix is a development environment. So we've not talked about how to write code. Today, you know, for the past couple lessons, we've all been doing it in our browsers. through Code Academy. And then in the last lesson, we introduced the concept of executing JavaScript directly using Google Chrome developer tools. Of course, that's not how most professional developers write code, but we're getting to that. And as a stepping stone, Remix is perhaps, again, not what most professionals use, but it provides a real development environment in your browser. So there's no installation of anything required. So we're going to take a look at that at the end of the class about how to launch it. And this is meant for Solidity smart contract development. We're then going to look at an example of some Solidity code. We're not quite ready yet to fully build our own smart contracts, but you're getting to a point where, as we showed in the last lesson, you're able to execute through Google Chrome some existing Web3 calls against MetaMask. We're now going to take a look at what does Solidity code look like? And specifically, we're going to look at the ERC721. This is called a non-fungible token. If you've read anything on any newspaper about blockchain lately, the NFT or non-fungible token is, exploding in popularity and it's changing the world. Well, actually, it's pretty simple. It's really a simple concept that we're going to be able to just take a look at how the source code works. And although you may not fully understand how to build it yourself, I think by the end of this lesson today, you'll be able to appreciate what functions are happening in the ERC721 and just how simple it is to work with Solidity code. All right. Before we jump on into lesson 4 fully, I do want to, first of all, apologize. Last time, lesson 3 did not go to plan. Our Zoom session cut off, and there were some difficulties. So I do want to make sure, please, if you have not gotten a chance to go through lesson 3, take some time to go do so. Conditionals are going to be something that we use in and out. And if you're not fully understanding what are ternary operators or how to get through the lesson 3, you really should spend some time going back and doing so. Feel free to reach out to me on Discord or WeChat and ask me more questions if you have any confusing items there. But now here we are. This is lesson 4 within Code Academy. The first thing we're going to be doing is going through some basics of what are functions. So just like I did the square, they're now giving an example here where they want to calculate the area of a rectangle. Pretty basic. So if you remember back to your introduction to geometry classes, we take our width and our height, and to calculate the area, it's width times height. So area is just a constant, width times height. So if we wanted to, we can make this a function where we could say the area of the first triangle is area 1, the area of the second triangle is area 2, the area of the third triangle. We get the point. We're kind of repeating ourselves over and over and over again with width times height, width times height, width times height. That's really repetitive, and it would be very hard to maintain all the code. What happens if we ever, needed to change how we wanted to compute areas? Well, it's better to just use a function to make it consistent. So in the example here, they're saying, take a look at the provided GIF. This is a graphic. It shows a function where this triangle comes on into this mystery black box, some magic stuff happens, and voila, out pops a square. Interesting. Okay, so what they're trying to show in this is that we have functions like add one side, and if a pentagon comes on in, you can now see a hexagon with 6 sides come on out. So take a look. It's kind of an example. So what it's doing is allowing an input like a triangle, 3 sides, come on into the add one side function, magic happens, and out pops another object that now has an additional side, 4 sides, a square. Make sense? This is just conceptual. Let's go do it for real. So how do you make a function? Well, as we described earlier, you need the function keyword. You literally have to type out the word function so that JavaScript will know you're intending to build a function. It then requires an identifier. So in this case, greet world is our identifier. It's the name of the function. We then follow that with some parentheses where optionally we can provide inputs, one or many, or in this case, none, which is totally fine. We have no inputs on this function. We then use the curly bracket to signify the start of the function. You can then put your procedure on into it, console.log hello world. And then we finish the function by putting a final curly bracket. And what's going to happen is it's going to match up the starting curly bracket and the end curly bracket to say this is the function body. So if we ever call greet world, what we should expect to see is that hello world is going to be printed out on the console. So let's go ahead and try one. Let's create a function that prints a reminder to the console. Using a function declaration, create a function called getReminder. Apologies, my browser seems to have disconnected. Give me a moment. There we go. All right, function getReminder. And it's important to make sure that the capitalization is matching exactly what they have here. Again, this is taking no inputs, so I'll just use parenthesis, parenthesis. And at the moment, it's just a declaration. So in fact, we don't even have to use the curly brackets, just as they've shown here, greet world. This is called a declaration. It's saying we have a function and declared it, but we haven't actually defined what it's going to do. So from a declaration point, we have now, well, almost. Let's see what's wrong. Let's create a function that prints a reminder to the console using a function to create a function called getReminder. I believe that's all they wanted. There we go. Sorry, they wanted it to actually have the curly brackets. In the function body of getReminder, log the following reminder to the console: water the plants. So all we have to do for printing anything to the screen, again, we're going to use our console.log, and then we'll put in water the plants. So at this point, this function is pretty basic. It's not actually doing anything other than just always, if you call the getReminder, it's going to call water the plants. In fact, as you can see, when I ran this, nothing printed out to the screen. Why? Well, although we've defined the function, we've actually not called the function. So we'll come back to calling the function at a later point. But you can see that at this point, you've defined something in the code, but it never actually runs when you click run. It just is defined, but never executed. Let's create another function that prints a useful Spanish travel phrase to the console. Okay, so function again, greet in Spanish. And again, we can leave it blank for the time being. Let's run this. Great. So at this point, we have two functions that are defined but not executed. Add code in the function body of greet in Spanish. Okay, so we're going to do a console.log, and we're now switching to Spanish. Buenas tardes. Buenas tardes is now defined. In fact, I forgot a period, so I'll fix that now. All right, so as you can see, just because you define a function doesn't mean anything's going to execute. If we wanted it to execute, we would actually have to call it. And because this function has no inputs, we can call it by simply passing the two parentheses. If you were to forget them, you'll notice this is not valid. That doesn't make sense. You need to be able to say that even though it has nothing, you need to say it is a function based on the fact that we have parentheses next to it. Okay, I think this is pretty basic. Let's keep moving. So now we're getting into, well, how do you call the function as I just showed? So to call a function, you need to use the identifier with the parentheses. So again, get greeting, if we wanted to call get greeting, we would have to say get greeting and then provide the parentheses. You have to call a function after it's been defined. You just can't do a call of a function that has not yet been defined as. And once it's been defined, you can call it as many times as you wish. All right, let's try some examples. Imagine that you manage an online store. When a customer places an order, you send them a thank you note. Let's create a function to complete the task. So let's define the function, say thanks. So function, say thanks as a function declaration. In the function body of say thanks, add code such that the function writes the following thank you message to the console when called. All right, blah, 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 blah. Copy, paste, semicolon at the end, run. Great. So in order to actually call this, we have to actually call it, write down the identifier, say thanks. Great. Now it's actually calling the function. Imagine that 3 customers placed an order and you want to send each of them a thank you message. Update your code to call say thanks 3 times. Say thanks, say thanks, say thanks. Run. Great. We're seeing that we now have an ability to run the same code arbitrary number of times. But again, it's pretty useless. Normally, you may want to say, say thanks to an individual customer, like who is the customer, and then modify what we're saying based on that. So we're going to get into that in a bit. This is where we need to be able to pass inputs to our functions. Next. These inputs are what we call parameters and arguments. So let's observe how to specify parameters in our function declaration. Like in the example of calculating the area of a rectangular square, we would need the width and height as parameters. Those parameters can then be reused inside of the actual function, console.log. We can then, when calling a function, pass in arguments as values. So we use 2 different words here. Parameters are what we put in the function definition. Arguments are when we're actually calling the function with the identifier. Those are the arguments are what we're passing into the parameters. Fancy words, but realistically, they're doing the same thing. You just need to say when we call a function, you may want to pass in arguments, which then get used in the function itself. So the say thanks function works well, but let's add the customer's name to the message. Add a parameter called name to the function declaration for say thanks. Name. Again, we could call it this variable anything we wanted, but to follow the instructions, we're using the word name. At this point, nothing has changed. We have added a parameter of name, but we've not used that parameter at all in the actual execution. And again, since we're not calling the identifier this function, when we run it, nothing is printing out yet. With name as a parameter, it can be used as a variable in the function body of say thanks. So let's go ahead and modify this existing code to now include a name. To do so, I've just added a space. I'm going to put another quote mark to say I'm stopping the thank you for your purchase string. I'm then going to use the plus argument to add my name variable. I'm then going to use another plus sign and add on a single tick mark, or a single quote, and then the rest of the string. So what we're seeing is a string, plus sign, a variable called name, which we expect to be a string, plus sign, another string. We're then what's called concatenating multiple strings together. All right, let's run it again. No change. Why? Because although we've changed the function to include the name, and we now use the name inside of this actual function, we've not actually called this identifier and passed in any arguments. So let's do the last one. A customer named Cole just purchased something from your online store. Call the say thanks function and pass Cole as an argument to send Cole a personalized thank you message. Say thanks. Now, Cole is a string. We want to make sure that we don't accidentally pass in a variable, but we could if we wanted to. And we then click run. Thank you for your purchase, Cole. We appreciate your business. Now, the grammar Nazi in me wants to say, yeah, okay, either way. And in fact, if we wanted to, we could create a variable There are many ways to go about this. As you can see, there's different ways you can solve this. So we can start combining these concepts together to then say we can have a variable which captures what our customer name is, and then we use the say thanks function to then execute the variable, which references Cole, which then comes on back to this. You see how it's all coming together. Default parameters. So this is a newer feature in JavaScript. So in ES6, one of the newer versions of JavaScript, we can now have the ability to use default parameters. So this is a cool feature. Default parameters allow parameters to have a predetermined value just in case no arguments passed into the function, or if the argument ends up being undefined, whether purposely or unpurposely, when called. So let's take a look at the code snippet. We have the function greeting and a name equals stranger. So previously we passed in a parameter called name, but what we're seeing now is this equal stranger is now a default parameter, meaning that should name be undefined when called, that's okay. We'll still execute without an error, and it'll default to stranger. So if you say greeting Nick, no problem, name will equal Nick, and it should say hello Nick. But if you accidentally called greeting without passing in a name, it won't error out. It will now have a default value of stranger. Okay, let's try the example. The function make shopping list creates a shopping list based on the items that are passed to the functions as arguments. So function make shopping list, item 1, item 2, item 3. This is kind of a silly way of going about it. Like what happens if I need item 4 and 5 and 6? But let's hold off on thinking about how we would solve it for any arbitrary number of items and assume that a shopping list always has 1 to 3 items. So create a shopping list based on these 3 items. Imagine that you always purchase milk, bread, and eggs every time you go to the shopping for groceries. Make a grocery list easier. Let's assign default values to the parameters in make shopping list. So they want us to assign milk as the default item for 1, bread as the default item for 2, and eggs as the default item for 3. All right, this is pretty straightforward. We're just adding equal signs. So milk, item 2 needs to get a default value of bread. Item 3 needs to get a default value of eggs. Again, when we run this, nothing should happen. We've not called the function. If we wanted to, though, we could then call this function, make shopping list. And what's interesting is we can now run it without any arguments. And sure enough, milk, bread, and eggs now all get populated in here. And if we wanted to, what happens if I said eggs, bread, and milk? Let's see. Well, it also would help if I put them as strings. So what we can see is, although the default values were defined up here, we can override them. We can make item 1 show up as eggs. And there's nothing that'll stop us from doing that. Eggs, bread, and milk now appear in reverse order. Let's play around with it some more. What happens if I only pass in eggs? Egg, bread, eggs. Understand? Because we only passed in 1 argument, by default, item 1 was set. Item 2 and 3 didn't have anything defined. So they defaulted back to the defaults, bread and eggs. So now we're ending up with 2 eggs and no milk. We can extend that further. It's perfectly possible to have eggs and milk and no bread. Okay. Hopefully this makes sense. Let's move on. So up until now, we've actually not been returning anything in our functions, meaning that we defined a function, it did some procedure, and we didn't have anything go back. When we print something out to the console, technically that's not a return, that's just doing a procedure. What we normally want to do with a function is make it able to return a value. Like in the case of calculating a rectangle's area, we don't want to just always print out width times height and just print the area to the screen. Maybe we want to print to the screen, or maybe we want to save it into a variable. So normally what we would want to do is have a return. The way that we define returns is to literally say in the function, return, and then something. Now, normally you might return, a variable back, but it's perfectly possible to return back a constant if you wanted to. All right, let's go ahead and give it a shot on one of these examples. Imagine if we needed to order monitors for everyone in an office, and this office is conveniently arranged in a grid shape. We could use a function to help us calculate the number of monitors needed. Declare a function monitor count that has two parameters. The first parameter is rows, and the second parameter is columns. So again, we're declaring a function, so we write function first. We've made the identifier called monitor count. And we say we need two parameters. The first parameter is rows. The second parameter is columns. In the body, we've not defined how to do it. I think it's pretty obvious, but let's go ahead and just solve number one. Okay, step two. Let's now go solve it. Let's compute the number of monitors by multiplying rows and columns and then returning the value. So in the body of the function you just wrote, use the return keyword to return rows times columns. So again, the return keyword is built into JavaScript, and by doing so, we're going to be able to use this to return a value back, rows times columns, semicolon. Run. So at this point, we've completed exercise 2. Nothing is displaying here, but we're now, instead of printing anything out to the screen, we can now do arbitrary things with it. So we might say console.log monitor count, and if we had 5 rows by 6 columns, we could console log that on out, 30. Alternatively, we don't have to directly put it on out to screen. We could let the count equal monitor count. And now we have it stored in this variable. So it gives us more flexibility by returning a value. Many times when we're defining a function, we want it to do the least number of things possible so that it's very easy to maintain. In this case, returning back a variable of the monitor count just as the integer itself is perhaps the best thing to go do. If we want to print it out to the screen, it's better to then call the console.log to print it out to the screen. Let's do exercise 3. Now that the function is defined, we can compute the number of monitors needed. Let's say that the office has 5 rows and 4 columns. So 5 rows and 4 columns. Declare a variable name number of monitors using the const keyword, number of monitors, and assign number of monitors the value of invoking monitor count with the arguments 5 and 4. Now, it's erroring out because I managed to change the variable and forgot to update the console.log, but you wouldn't make that mistake. And finally, number 4, make sure that you log it out to the console, which we've now just done. Okay, let's keep going. Helper functions. We can use the return value of a function inside another function. These functions being called within another function are often referred to as helper functions. Since each function is carrying out a specific task, it makes our code easier to read and debug if we have to. If we wanted to define a function that converts the temperature from Celsius to Fahrenheit, we could write 2 functions like function multiply by 9/5. So if you take a number and you multiply that number by 9/5, it turns out that's a good way of calculating how to get Fahrenheit. So function get Fahrenheit of Celsius. So if we pass in a number and then we multiply by 9/5 the Celsius number and add 32, that would be a way to get Fahrenheit. Let's give it a shot. In fact, before we jump on in, I want everybody to see this running. Oh, I guess it's not going to let me because it wants me to do the exercise. Well, fine, we'll do the exercise. In the previous exercise, we created a function to find out the number of monitors to order for an office. Let's write out another function that uses the monitor count function to figure out the price. So we got the monitor count already here. Price then would be dependent on the cost of the monitors. So below the monitor count, create a function declaration named cost of monitors that has two parameters. The first parameter is rows, the second parameter is columns. Leave the function body empty for now. So I'm making a new function. It's called cost of monitors. And again, it's still taking the same parameters of rows and columns. They've asked us to leave it blank. Let's run it. To add some code to the function body of cost of monitors to calculate the cost, add a return statement that returns the value of calling monitor count rows and columns multiplied by 200. So we can use this monitor count function within inside our cost of monitors function. We're going to pass in the exact same parameters, rows, columns. And it seems that they want to say that a monitor costs $200 or something. And they want us to return this as a result of running this function. So we put the return argument on in. So function cost of monitors, again, passing in rows and columns, is a fixed price of 200, which we're going to return on out by calling the monitor count function with rows and columns. Let's run that. Great. We should save the cost to a variable. All right, so let's declare a variable named total cost using the const keyword. So const total cost equals, we're going to assign it the cost of monitors. So cost of monitors with the arguments 5 and 4 to say 5 rows and 4 columns. Great. So at this point, we now have this stored in total const and in it total cost, and to print it on out, we could use a console.log and we could print on out, say total cost is what? $4,000. So 5 times 4, 20, 20 times 200, 4,000. So functions can be used inside of functions. We call that a helper function. If we wanted to, we could make this more flexible. The cost of the monitor might be variable. We could then say cost of monitors is actually a combination of rows, columns, and price. We could then remove this and make it more of a variable. Monitor count rows times columns times price, and we could then put the 200 here. Same behavior, now it's more flexible. And in fact, we could combine even more concepts to then put in a default to say, if you didn't specify a price, what would happen? Now, actually, I shouldn't make that a string, but you get the idea. That is the correct way. So this would allow us to have more flexibility by using a helper function and being able to have a default parameter of 200 such that if you didn't include the price, it would just know that it's defaulting to that. But if we wanted to, we could increase the cost now of our monitors, and it would be very easy to maintain. Okay. Keep building. Function expressions. So another way to define a function is to use a function expression. To define a function inside of expression, we use the function keyword. In a function expression, the function name is usually omitted. A function with no name is called an anonymous function. A function expression is often stored in a variable in order to refer to it. Consider the following function expression. Const, then we have our identifier, calculate area, equals the function keyword with our parameters, and then we put our curly braces to then define what is the procedure. We're going to say const area equals width times height, and we're going to return area. So let's try it. To declare a function expression, declare a variable name to variable's name to be the name or identifier of your function. Since the release of ES6, it's common practice to use the const as the keyword to declare the variable. So const calculate area equals, assign that variable's name as an anonymous function by using the function keyword, followed by a set of parentheses with possible parameters. Then a set of curly braces that contains the function body. So function. Now, what happened to the name? We don't have it. So width, height. And then const area is going to be width times height. And we're returning that area variable. Cool. Now, I've not followed the exercise, but this is an example of a function expression. You can see that the identifier is no longer after the word function. We've moved it now to this variable called const calculate area. And we've defined it now here. It's kind of like a shorthand way to make an expression without having to define it first. Let's say that we have a plant and we need to water once a week on Wednesdays. We could define a function expression to help us check the day of the week and the plant needs to be watered. Create a variable named plants need water using the const variable keyword. Const plant needs water. Assign an anonymous function that takes a parameter of day to plants need water. Again, we're making it anonymous, so all we need is the word function. And the only input it needs is day. Now, at this point, we've not defined what to do with it, but that itself satisfies the first instruction. Do you see how it works? Previously, we would have said function, plants needs water, parentheses, day. It's the same thing. We could have done this. We could have just said, these two things are equivalent. This expression, though, makes it a little simpler when we want to quickly be able to construct and save things to a variable. Now we need to add some code to the function body of plant needs water. In the function body, add an if conditional that checks day equals Wednesday. So if, this is our conditionals from last exercise, day equals Wednesday. If the condition is truthy, meaning it's true, inside the if code block, return the keyword to return true. So we can say inside here, return true. Run. You're not going to see anything here, but if we wanted to, we could actually call this. On days that aren't Wednesday, plants need water should return false. So by default, although it's returning true, it's not going to return anything if you were to pass in something other than Wednesday. To make it do that, we would have to say else return false. Let's run it again. Again, nothing should happen, but we've now defined it. So now let's call plants need water and pass in Tuesday. Plant needs water with Tuesday as the day parameter. So nothing has printed to the screen. Why? Because all we've done is return false, but there was no way to print it out. If we wanted to, though, we could console log this and see what it's doing. Sure enough, false. And that completes the fifth exercise. Okay, I'm going to leave the remainder of these exercises for homework. There aren't too much left, and they're not too hard, as you can see. Just try to go through it. The arrow functions is a bit confusing and very important. We'll talk about this more next time. But with the remainder of the time, I do want to at least show some of functions happening within Solidity. So I want you guys to take a look. I'm going to post this on into the Discord. I want everybody to try doing this for homework. And this is going to be a bit hard, but you're going to figure it out. We're going to create an NFT and deploy it to a public testnet using Remix. You guys are almost ready to start understanding at least how to read the Solidity code. And Remix, again, is the development environment. If you follow this guide, you can click on remix.ethereum.org. And I recommend using any Chrome-based browser, but you can use Firefox or others. You're going to get an environment that looks very similar to this. Once you're inside the Remix IDE, make sure you're on this File Explorer option. That's going to show you all the files that you have. If you click it again, it's going to collapse that. So just make sure you can see the File Explorers listed here. By default, it's going to include some default code. Just ignore it. We're going to create our own. Let's follow through this. So importing the contract. We're going to use a preset, meaning it's already been built, ERC721 preset minter pauser auto ID, which is an ERC721 that is preset so it can be minted, paused, and burned. We need to import this code on in. In fact, if you open this code up, you can take a look at what they're talking about. ERC721 has these functions. Hey, functions, just like JavaScript. And they have parameters, just like JavaScript. We've not talked about what a constructor is, but basically this is a function to say when you create something, what are the required inputs to be able to create this new thing? So the thing we're creating is an NFT, and an NFT is defined as a name, a symbol, and a base URI. So the name can be anything you want to give it. So we could say the name is cat GIF, and the symbol is when we're trading an NFT on an exchange, it's just a shorthand set of letters and or numbers to define how to reference it. Again, it's anything you want it to be. The standard is usually you try to pick something fairly unique so that it doesn't accidentally confuse people. So if your name was cat GIF, maybe the symbol again would be, cat G, whatever, doesn't matter. You can pick whatever you want for the symbol, but it's usually just a few letters, 3 or 4 letters. The base URI is meaning where's the website of the thing that you're creating an NFT on. Now this is kind of confusing for even people that are in blockchain. What's the point of making an NFT that just points to a website? It doesn't prove anything. I could go make an NFT of the Mona Lisa. It doesn't mean I own the Mona Lisa. Normally, what you would want to do is provide a base URI of a web URL that you actually own. And the point around this is to attest on the blockchain that you own this particular thing. Now, if you lie, there's nothing to stop you from lying. You can go say, yes, in fact, I am the Louvre and I own the Mona Lisa. Nobody's going to be able to stop you, but nobody's going to trust you either. By using a base URI that you control and by creating many NFTs, you start to create a provenance of data that other people begin to trust you to say, this person really did own that at this point in time. And so now that we have this concept of an NFT, you can transfer it to other people. And it means that you're now transferring the ownership of that. So just like anybody in the world can go make a fake reproduction of the Mona Lisa, doesn't really change the fact that there is a Mona Lisa and that somebody in fact does own it. And if they were to create the NFT, they could, if they wanted to, move this digital object around on the blockchain to show who is it transferring legally ownership to it. Interesting concept. Let's go try playing around with it. Let's go back to this. So in order to make an NFT using this code, we're going to import, we're going to create a new file. And they want us to create a new file called Open Zeppelin Preset Contracts. So I'm going to copy and paste this, go back to Remix, and wherever you want, go ahead and create a new file by clicking this Create New File icon. It's going to bring up a little dialog box here where you can paste in what you want. By default, you're going to want to make sure all the files you create are using .sol at the end. This is to indicate it's a Solidity code. Great. So I now have my open Zeppelin presets contracts.sol. In the new file, we're going to import the statements for the ERC721 that we're creating. So one of the great things about Solidity Code is you can actually import other code on in it. And they have an example here. Let's take a look at what it's doing. The first line is a comment. Just like JavaScript, you can create a comment with 2 slashes. This comment is actually indicating the license agreement. It's saying it's an MIT license, which is an open source type license that allows us to reuse this without having to pay any money. The next line is very specific to Solidity. Pragma, Solidity, then a caret symbol, and then this string of numbers. What in the world is that? When we're writing Solidity code is actually compiled. And this is indicating what version of the compiler do we need to use. This little caret symbol indicates it needs to be greater than 0.6.2. We're not going to go into today exactly what this all means, but just take it as truth that this has to do with how is the compiler going to get picked and making sure that our code is compilable. So copy and paste away. The last line, which is difficult to read, let me copy and paste it on over and it'll be easier to read here. It says import, and then it passes in this URL, github.com, open Zeppelin, blah, 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 blah. And it's copying on in this code. In fact, if you copy this URL, you can go over to a new browser window, paste it in, and go look at this code in GitHub. And I encourage you to go do so. This is literally going to then say to Remix, I'm not writing out all this code. Instead, I want you to go out to GitHub and fetch this code that's already been written. This is an open source code where you can even see it imports even more code and even more code and even more code. They've organized this so that you don't have to read all the code. And this is a good example that implements the ERC721 standard for how to make a Ethereum NFT token. Very similar to JavaScript, they have some comments in here. So /**, which is slightly different, starts a multi-line comment. And here's some documentation in the code as to what's going on. Saying an ERC721 token includes an ability for a holder to burn or destroy the token, so you can literally delete it. A minter, meaning the person who creates it, role that allows new token creation. A pauser role that allows all token transfers from happening. And then finally, we need a token ID and the URI. You can also use access control to lock different types of permissions, and that's even more complex than we're going to get into today. Sadly, we don't know enough about Solidity yet to read all this code. We've not got into what bytes are and everything else, but I think if you start looking at some of these basic functions, you're going to start seeing some things that look similar. This is a function, the constructor function. Remember that an NFT requires a name, a symbol, and a base URI. What's different about Solidity from JavaScript is it's called what's called a typed language. Typed languages mean variables have to be defined not just by name, but also by what type of object are they. So an integer is very different than a Boolean, is very different than a string. So when we say this variable is a name, we have to be very explicit about it. Say it's a string. I'm not going to go into what memory is. Let's just assume that you understand that we'll get to that later. Again, a symbol is another string, and the base URI is another string. It then has another keyword here called public. Public is another interesting thing about Solidity, where certain functions can be made public and others private, meaning whether or not people are able to expose it and use it. In this case, it is exposed, so it's public. This is the identifier. So just like JavaScript, we can give functions a name. This is the identifier for the ERC721. And for a constructor, it's going to be the same. And then it has a name and symbol. This actually got inherited from other code up here. And again, we're not going to be able to go into all this today, but it's actually not too complicated if we go back into Remix. All we need to do to create an NFT is literally say, what's our compiler and where are we importing our code from? What we can then do is go into the Solidity compiler tab. Click on this. You'll see that it's selecting a compiler that's then compatible. There are many, many different versions out here. In this case, it's saying it must be above 0.6.2. So just ensure these numbers, 0.612 is more than 0.62. And it doesn't matter a whole lot for right now which one you select, as long as it's greater than. Then we're going to say the language is Solidity. There are other types of languages we're not going to get into. All the defaults here are all fine for what we're doing today. Just leave it as compiler default and leave these unchecked. Go ahead then and click on Compile OpenZeppelin Preset Contracts. Cool. At this point, now that it's compiled, you can go and select it. So go to your contract, and we're going to select ERC721 Preset Minter Pauser Auto ID. And I apologize, I'm skipping past some things, but let's take a look at what the documentation says. So it said, yes, compile the contract, we did that. Now we're getting to the point where we want to deploy it. So we can deploy our new token to a development blockchain. Turns out all of you guys on this call already have some Kovan testnet. So make sure you go to your MetaMask, make sure you're on Kovan test network. Don't put this on the main net right now. You're going to spend a lot of money. Make sure you're on Kovan testnet. And make sure you have some test ETH. You only need a little bit. I've got way too much, but you should have a little. Let's go back to Remix, and we're going to deploy and run this plugin. We're going to deploy this. So click on the third one now, deploy and run transactions. For environment, you're going to want to make sure it's selected to injected Web3. By doing so, that's going to read the MetaMask injected Web3. There are other ways of doing it. We're not going to talk about how to do them, but it is an injected Web3 provider. It then detected that I am already on the Kovan network. You might make sure you double check. Don't accidentally put it onto the main net. And then it's going to automatically detect what your Ethereum address is. You can verify this is the correct address. The gas limit, you can increase this safely on up. They suggested, I believe, was it 5 million? Yeah, 5 million, just to be safe. Make sure that you're specifying the ERC721 preset minter pauser ID. And then you can specify your name, symbol, and base URI to say, I am using my NFT, and then whatever you want. Let's go ahead and search for a cat GIF. This one's cute. Yeah, that'll do. And I am now going to say I am the owner of this cat GIF, which is clearly false, but it doesn't matter. It's just the blockchain. So I am going to go to my contract. Now I have many contracts in my development environment. I apologize. Just make sure you select the ERC721 pauser, preset minter pauser auto ID. That's the one we're working with. Then it's going to say deploy, but it has our function. There's the constructor, name, symbol, base URI. The base URI is my cat GIF. I'm going to literally pass on in my GIF. The name can be anything I want to do. I'm going to call it cat GIF off chain. Sure, you can put spaces, whatever you want in there. And then let's call it cat off chain. Sure, that's my symbol. Doesn't matter. At this point, you can now transact. Invalid transaction param specified if okay. Perhaps I won't be transacting today because my Trezor wallet does not support EIP 1559, and well, I forgot about that. Let me switch to a different one and see if I can get this to work. I forgot that I don't have that on my Trezor. Can I do it? Probably not. I don't think that's going to make a difference, will it? Fine. Bear with me a moment. I'm going to need to create another account and send some test ETH to it. You should not hit the same problem. I do apologize. Okay, I've now sent some test ETH to my alternative wallet, which should not have this problem that is specific to my hardware wallet. Sure enough, it does have my 0.1 ETH. We're going to switch on over here and no problem. Hopefully this works. All right, I'm now on my alternative one. Apologies. You shouldn't have to specify any value here. And if I did this correctly and with any luck, hooray. It now is interacting with my wallet. It's saying for this, it's not going to use any ETH because I'm not sending ETH, but it will use some gas, which is measured in ETH. So I'm spending 0.00936 to go do this. I'll click confirm. It's now actually interacting with the Kovan testnet, and I now have deployed my cat GIF to the Ethereum testnet. If I go back into MetaMask, you'll see that it has an activity of contract deployment. If you click on it, you can click on View Transaction on Etherscan. This is the Kovan Etherscan. It's still pending. But it is now creating this contract, and we can, once it's been completed, we can take a look at it. Sure enough, it's now successful 33 seconds ago. And if we see more, what we can see is that it's put all this input data as encoded information. We really can't view anything about this at the moment. But in fact, within this encoded information is our ERC721. How do we interact with it? We can use Remix to do that. What we can do is then say our contract is now going to be this contract here. It's created it. At the moment, we can't view anything other than this really messed up code. In fact, in another example next week, we'll talk about how you can verify and publish this and make it very, very easier to read, but we're not going to get to that today. Let's go ahead, though, and load our contract. So I'm going to paste in the contract that we created. And then from here, we can then start to interact with it. So we can see down here, here's my contract, and we can do things against this contract using the functions that are part of an ERC721. So let's see if we can call the name. I call the name function. And if we expand this on out, you can see it retrieved cat GIF off chain. Cool. This is proving that within that really, really difficult to read code that's now on the blockchain, there are now functions that we can call. Some of these functions have no arguments. Like in the case of name, you don't have to pass in anything. It's just literally reading what is the name of this 721. Or in the case of symbol, I can call the symbol function. Again, no arguments. And it's getting the result cat off-chain as a symbol. And if I wanted to, I could go and get the URI as well. There, in fact, is our base URI, which is pointing back to our cat GIF. It's a really, really basic smart contract. It really doesn't have all that much. There are some things that we can do here. They say I can change who owns it, so I could transfer this token to somebody else. So if I wanted to, I could transfer it from one person to another. I could create additional NFTs. There's many things you can do with an NFT. Go ahead and try this out for yourselves, guys. This is not that hard, but it's a very basic building block of how smart contracts are being built. It's perhaps one of the easiest smart contracts you can work with, and it gives a really good understanding of what you can then do with it. I hope this has been helpful. I'm going to go ahead and say we're going to close the class here. Please complete lesson 4 for functions and try giving this a shot. I really would hope that everybody here can feel comfortable going through this exercise. It's all fully documented here, and they've got some really great examples of what you can try out here. Try creating your own NFT. If you get stuck, just reach out to me on Discord or WeChat, and I'm happy to help out. Once you've created an NFT, this is literally what you can then go sell on OpenSea. So if you were wanting to, you could then publish some picture. Perhaps you're an artist, or it doesn't have to be a picture. It could be an MP3. There are now recording artists making loop traps and other things that they want to publish on out here. All it's doing is just putting on a blockchain that you own whatever this URL is. Okay. Okay. I'll now stop the recording, and if anybody wants to ask any questions, feel free to go ahead and just ask away. Just give me one moment.